It was for glycolysis, isn't it? So we saw in glycolysis that due to enzymatic reactions provided in the cytoplasm, the glucose, that is a 6-carbon molecule, is converted into 2 molecules of 3-carbon component called as pyruvate. So what we saw in glycolysis, that is 6-carbon glucose is converted into 2 molecules of 3-carbon pyruvate. Fine. In the presence of enzymes, that is in general catabolic in nature, which provides or produces energy in state of in form of ATP. यही देखा हमने, right? What is the end product? End product is pyruvate. Fine. So pyruvate is formed in cytoplasm. But what is the fate of pyruvate? किस्मत क्या है? What is the fate? Anyone can just suggest me. What is the fate? Like, what is your fate? You are going to complete your degree. You will be practicing as an medicine practitioner. Then you will go for PG. This is what your fate is all about. Whether you will get married, you will have children, XYZ. This is fate. What is the fate of pyruvate once it is formed? Anyone? It has, very good. It has got no fate other than moving into mitochondria. The pyruvate formed or the pyruvic acid formed in cytoplasm has got no fate left in cytoplasm. It has to immediately move inside the mitochondria, provided by a transporter that is specifically named on pyruvate, called as pyruvate transporter. Okay, called as pyruvate transporter. याद रखिएगा, ये बहुत बार multiple choice questions में आते हैं. They will give you different names of transporters, but it's specifically called as pyruvate transporter. Okay, that is present in the inner membrane of mitochondria, because outer membrane of mitochondria is almost permeable to many of the solutes, but the inner membrane is selectively impermeable or selectively permeable to certain specific solutes. And the solute we are talking about is pyruvate. Okay. Now, what is the fate of pyruvate inside mitochondria? See, the pyruvate came inside. This pyruvate has got 2 possible fates. How many? 2 possible fates. And both of them are occurring in a different storyline, or you can say in a different condition. Okay. The first fate that has been taught yesterday only for you guys is gluconeogenesis. Yes or no? Yes or no? The other fate is pyruvate can convert into acetyl CoA. Fine. देखो मैं concept बता रहा हूँ, पढ़ना कैसे. You remember the last reaction where phosphoenol pyruvate converts into pyruvate? That was an irreversible reaction. Okay. So to convert pyruvate back into phosphoenol pyruvate, you require how many reactions? You require 2 compensation reactions or 2 compensatory reaction that converts pyruvate back into phosphoenol pyruvate, that is required for gluconeogenesis. Yes or no? The enzyme name is pyruvate carboxylase, another name is pyruvate phosphoenol pyruvate carboxykinase. पढ़ा है ना कल? पढ़े हो? Yes or no? Fine. And that reaction requires ATP. It's an energy involving reaction because it's an anabolic process. This acetyl CoA formed from pyruvate, because pyruvate has got no other fate. Either it will convert into acetyl CoA or it will convert into a gluconeogenic precursor or substrate. Forget about this. You have been already taught. Okay. Now we will majorly focus on what if the cell is in need of energy, is in need of ATP. The only fate left for pyruvate is that pyruvate will convert into acetyl CoA. ठीक है? Acetyl CoA has got 2 more fates. Acetyl CoA can go for TCA cycle or it can go for fatty acid synthesis. अब interesting बात ये है, TCA cycle occurs in the matrix of mitochondria, acceptable, but fatty acid synthesis occurs in the cytoplasm. ठीक है? Fatty acid synthesis is an anabolic process. Yes or no? Anabolic process. We are forming something. ठीक है? This reciprocality or this functioning, that whether the cell wants TCA acetyl CoA to go under TCA cycle and get completely oxidized, whether the cell wants the acetyl CoA to go for fatty acid synthesis, what decides that? Who is going to decide that? Of course, the cell will decide that. But what is going to be there inside the cell, that is going to decide this performance. This reaction to take place. Whether the acetyl CoA will go into TCA cycle and get completely oxidized, whether the acetyl CoA will go for fatty acid synthesis. What decides? You understand between two things, that is one catabolic reaction and anabolic reaction. What is the difference? Catabolic produces energy. Breaks certain thing, produces energy. Anabolic thing forms. I've told you, na, whenever you are joining two things, you require energy. Yes or no? Right? So anabolic reactions are responsible for requiring energy. They require energy. So just imagine your cell is having a low state of energy. Okay? And can you go for anabolic reactions? Your cell is having low ATP. Can you go for anabolic reactions? Point number 2. Your cell is having very less amount of ATP. Or very high amount of ATP. Can you go for anabolic reaction? Yes. ठीक है? So the sparing, ये point को याद रखिएगा. Sparing of acetyl CoA. Spare कर रहे हैं, जाने दे रहे हैं. Sparing of acetyl CoA for the production of fatty acid synthesis symbolizes or gives you an information that the cell is rich in energy. The cell is rich in ATP or energy. Yes or no? But if acetyl CoA is channeling towards TCA cycle, is entering towards TCA cycle, it gives us an information about that the cell is going to have less amount of ATP. Yes or no? Or the cell is lacking of energy, is having less amount of ATP. Yes or no? Clear? TCA cycle is one of the cycle or one of the metabolic pathway that produces maximum amount of reducing equivalents or that produces maximum amount of energy in form of ATP. ठीक है? Yes or no? Is that clear? ये concept समझ में आया? So this is about the energy demand and energy present. If energy is already high in the cell, TCA cycle gets blocked. ठीक है? If energy is high again, TCA cycle gets blocked and acetyl CoA is spared for fatty acid synthesis. Okay? If energy level is low, the cell needs energy. Acetyl CoA is spared from fatty acid synthesis and the acetyl CoA moves into TCA cycle. Clear? Yes or no? So as I told you that pyruvate has got a fate provided in this condition that it has to convert into acetyl CoA. This is provided by a complex of enzyme called as PDH complex. What is that called as? PDH. PDH stands for pyruvate dehydrogenase complex. Okay. It is one of the specific example of multi-enzyme complex. What is multi-enzyme complex? Just imagine करो एक joint family है, ठीक है? चाचा जी है, पापा है, ताऊ जी है. ताऊ जी का बेटा और आप में डिफरेंस है. You are not from same mother, right? चाचा के बेटे हैं तो उनका और आप में डिफरेंस है. You are not from same mother. He belongs to other mother. You belongs to your mother. In that scenario, एक joint family मतलब एक घर के अंदर है. They are staying under one roof and they are functionally different. ठीक है? चाचा जी खेती बाड़ी कर रहे हैं, पापा जी कहीं और काम कर रहे हैं, ताऊ जी कुछ और काम कर रहे हैं, लेकिन जो तीनों मिला के जो पैसा आ रहा है वो एक स्पेसिफिक घर को चलाने के लिए चल रहा है. Is required to run a specific home, that entire home. So that is called as a multi-enzyme family, or you can say, a joint family, or you can also call it as a multi-enzyme complex, where three different or many more different parts of enzymes, they play together a significant role to perform certain reaction to convert a substrate into a specific product. Am I clear? Can anyone say me if I'm saying this as a multi-enzyme complex? Okay, this belongs to which structure of protein? Secondary, tertiary, quaternary? पक्का? सोच के बोलो. Just raise your hand those who are saying it's a quaternary structure. Only one out of 150 almost. Those who are saying it as tertiary structure. Still 1, 2, 3. Many are remaining others, so they are not protein only. It's a protein in a. Why there is so much of confusion? But I have told you, if there is more than one specific protein segment aligned into one specific structure, the structure has to be quaternary supported. Hemoglobin has got 4 polypeptides, yes or no? Alpha 1, beta 1, alpha 2, beta 2. But when they are joined together, when they come close together and form a specific functional protein, that is called as a quaternary structure. ठीक है? So multi-enzyme complex will be a quaternary structure. Remember that. So PDH complex basically पता है कुछ सालों तक जब से CB में नहीं आया है, जब से recent CBME has been lost, PDH complex was a very important question for MBBS first year phase 1 biochemistry examination. PDH complex, very important. They will ask you. But nowadays, what they have done easier for you is that it was a big reaction. If you see Vasudevan book, it is a big reaction. You don't need it. You don't need it. What you need to know is PDH complex, as I told, it's a multi-enzyme complex. That means it will be having multiple enzymes, and multiple enzymes for their better functioning, it will be required of multiple coenzymes. So you must be aware of the names of 3 apoenzymes and 5 coenzymes. You must know the names. That's enough. You are not supposed to remember or mug off the reaction cycle. If you want me to draw, I can draw and explain you, but not needed. Okay, I'll try. The 3 apoenzymes, first enzyme is called as pyruvate dehydrogenase. Second is called as dihydrolipoyl. I'm short में लिख रहे हैं, transacetylase. The third one is dihydrolipoyl dehydrogenase. याद रखिएगा. These are the 3. This is what you need to know. यही पूछेंगे आपको क्वेश्चन में. Write down the coenzymes and apoenzymes and the 5 coenzymes of PDH complex. You are supposed to write the names of this. Okay. Pyruvate dehydrogenase, dihydrolipoyl transacetylase, dihydrolipoyl dehydrogenase. That's it. And the 5 coenzymes responsible are TPP. TPP stands for thiamine pyrophosphate. It's an active form of water-soluble vitamin called as thiamine. Okay. Next is coenzyme A. Coenzyme A is another active form of an amino acid called as pantothenic acid. Next is NAD plus, FAD plus, and last one is lipoamide. All are derivatives of water-soluble vitamins. All are derivatives of water-soluble vitamins. Niacin, flavin, lipoamide itself is a lipoic acid is another form of water-soluble vitamin. Pantothenic, thiamine. All are water-soluble vitamins. Okay. If you ask me, that's how this is happening. If you want to know, just in a very fast and furious kind of thing, we can move across. Pyruvate, short में लिख रहा हूँ, is a 3-carbon component, goes under this PDH complex. The first reaction is provided by an enzyme called as PDH. PDH, pyruvate dehydrogenase. यहाँ पे confusion है. Pyruvate dehydrogenase. नाम क्या बता रहा है? Pyruvate dehydrogenase. So what you are expecting the reaction should be performing? Removal of hydrogen ions, है ना? नहीं होगा. Exception है. It's only exception. ठीक है? Rather than that, this reaction can be called as oxidative decarboxylation. Decarboxylation. When we say decarboxylation, you must understand these 2 terminologies. Carboxylations mean addition of CO2. Decarboxylation means removal of CO2. In other terms, can we say that carboxylation means addition of carbon C to the substrate in the form of CO2? Can we add? Can we say like that? In the form of CO2. So the donor has to be CO2. Carboxylation, adding a carbon group. So if a substrate was earlier 2 carbon atom, then now after carboxylation it will convert into 3 carbon atom. So reaction is like that. Okay? If you are saying it to be as a decarboxylation reaction, that means you are removing a carbon atom in the form of CO2. Yes or no? So wherever you see that CO2 is coming out, just close your eyes and think that 1 carbon is getting lost out of the reaction. Is that clear? So this is a oxidative decarboxylation reaction where from 3 carbon pyruvate, 1 carbon is removed in the form of CO2. So the left part is the acetyl part, the 2 carbon part. Okay, that is accepted by TPP, thiamine pyrophosphate, that forms hydroxyacetyl TPP. Hydroxyacetyl TPP. So here the dehydrogenation reaction is totally playing a part for the removal of CO2, and the acetyl or the hydroxyacetyl part is accepted by TPP. यहाँ पे dehydrogenation reaction है, but it is following the same law. You remember the slogan? If someone has to donate something, someone has to be there. है ना? So here the component that is going to convert into rich is TPP. Okay. Later part, the hydroxyacetyl TPP now donates the acetyl part to lipoamide. See, this is what L. This is called as oxidized lipoamide. The structure should be like this. Lipoamide has got a sulfhydryl side chains. S bole to sulfur. है ना? Lipoamide has got a sulfhydryl side chains that is responsible to accept and donate hydrogen ions. आगे बहुत काम आएगा ये. बहुत जगह आप कोएंजाइम के फॉर्म पे लाइपोएमाइड को देखोगे. ठीक है? It can accept the other counterpart. So it accepts the hydroxyacetyl part and converts into the acetyl lipoamide like this. Acetylated lipoamide. This reaction is provided by the second enzyme called as dihydrolipoyl transacetylase. Transacetylase. Transfer. Acetyl. Acetyl group has been transferred. So the enzyme name is transacetylase. Simple. Clear? Next to that, this acetylated lipoamide transfers the acetyl group to an coenzyme A, which is again going to have a sulfhydryl thioester linkage that accepted by acetyl part and forms as acetyl CoA. Acetyl CoA. ठीक है? Rather, after that, it forms reduced lipoamide. Can you see the difference between this and this? This is called as reduced lipoamide, which reconverts back into oxidized lipoamide provided by FADH, accepts the hydrogen from reduced lipoamide and converts into FADH2. This FADH2 converts back into FAD plus provided by NAD converts into NADH. एक सवाल पूछता हूँ मैं, ये सवाल maximum time. If you are coming for the viva to me, I will definitely ask this. If you can remember, FAD plus converts into FADH2 in this reaction, right? Why the cell needs that this FADH2 has to donate the pair of hydrogen back into some other coenzyme? Like NAD plus except the NADH, this NADH goes into ETC, it gives 2.5 molecule of ATP. Why is it needed? Because we have already a coenzyme over here formed. FAD plus converted into FADH2. Then why do we need the FADH2 to donate the pair of hydrogen to another coenzyme, more sustainable coenzyme, that is NAD plus, so that it can convert into NADH? NADH goes into ETC. Why not FADH2 can go into participate into ETC for this reaction? Anyone? Have you heard about a terminology called as prosthetic group of an enzyme? Prosthetic part of an enzyme. Prosthetic coenzymes are called as prosthetic part of an enzyme. If the prosthetic, generally हम लोग क्या बोलते हैं? What we say, that coenzymes are organic molecules that are bound loosely. यही बोलते हैं ना? But if the coenzyme present in an enzyme complex is bound tightly, it cannot go out of the enzyme complex. We call them as prosthetic part. So in this reaction, FAD plus is a prosthetic part of the coenzyme. That means the FAD plus is bound tightly with the PDH complex. It cannot go out. It can reconvert itself, but it cannot go out and participate in ETC. That's why, as it cannot move out of the enzyme complex, it has to convert, or it has to donate the pair of electron that it has got to some other coenzyme that can participate in ETC and ultimately form an ATP. Is that clear? So this is the whole scenario which you are not supposed to remember. But what you are supposed to remember is this part. And the last part. This reaction is irreversible. The irreversibility nature of this reaction is responsible of a fact that you can convert, our body can convert excessive glucose into fat. Okay? Our body can convert excessive glucose into fat. But Because of the irreversible nature of this enzyme or this reaction, excess fat cannot convert back into glucose. Am I clear? Am my statement is clear? Okay? See, we want to know why? Because if our body is catabolizing the fat, we call that reaction as beta oxidation. You must have heard. Beta oxidation of fats. The end product of beta oxidation is acetyl CoA. It is acetyl CoA. And fats are made up of acetyl CoA. Okay? So if you break down fatty acids, what do you get? Acetyl CoA. Fine. So there will be a huge flood of, the cell will be flooded with acetyl CoA. Now, if this reaction would have been reversible, the acetyl CoA could have converted into pyruvate. Pyruvate can go under gluconeogenesis and convert into glucose. हो सकता था. Irreversibility nature of this reaction, acetyl CoA cannot convert back into pyruvate. Rather, acetyl CoA can move towards ketone body synthesis. Ketone bodies. That's why I have asked this question to some of you guys when we were doing practical, that what causes the formation of ketone bodies. We all say that, sir, diabetic ketoacidosis, starvation, prolonged history of vomiting, like in case of first trimester pregnancies and all. Generally, the body suffers from ketoacidosis. What causes the formation of ketone body? Incomplete digestion of fatty acids. What is that? Incomplete oxidation or digestion of, not digestion, oxidation. Incomplete oxidation of fatty acid. Because oxidation of fatty acid is producing acetyl CoA. So for complete oxidation of acetyl CoA, this acetyl CoA must move into TCA cycle. That's why we call the TCA cycle as a complete oxidation pathway. It's a final oxidative pathway, where the whole total carbon atoms are going to get removed in the form of CO2. So it's a final complete oxidative pathway. So because the acetyl CoA cannot go into TCA cycle in that scenario, the acetyl CoA moves into ketone body. So it's an incomplete oxidation of fatty acid causes formation of ketone bodies. Am I clear? Now, you can let me know what should be the regulation of this process, PDH complex. Be fast. I am drawing a diagram. Regulation समझने के लिए सबसे easiest diagram यही होता है. इसको बना दिया मैंने सूरज चाचू, इसको बना दिया मैंने चंदा मामा. ठीक है? चलो बताओ. The one with all the hairs, the spikes, like COVID virus, is active. The another one is inactive. Now you say, मैं hint दूंगा अभी. This is active. This is inactive. Yes or no? जल्दी बोलो यार. Fine. Listen to me clearly, because I have told you the trick to how to remember. What you have to know is a hint. A hint is PDH complex is regulated provided by two possible ways. One is covalent modification, another is allosteric regulation. Now the allosteric regulation is dependent on feedback inhibition. Okay. So what is the product of PDH? What is the product of PDH? Acetyl CoA. बोल क्यों नहीं रहे हो फिर? What is the product of PDH? So if there is excessive acetyl CoA, what will happen to PDH? Your cell is having already lot of acetyl CoA. खा के खत्म नहीं कर पा रहे हो, फिर भी खाना खाते रहोगे क्या? और ला दो मम्मी, और ला दो. So acetyl CoA will be acting as a feedback inhibitor. Whom it is going to inactivate? PDH. Point number 1, yes or no? दूसरा point मैंने क्या बोला कि it is covalent. PDH complex is regulated by covalent modification, phosphorylation or dephosphorylation, covalent modification. When it is phosphorylated, it becomes inactive. When it is dephosphorylated, it becomes active. Yes or no? Jaldi bolo. How it is going to, who is going to, covalent modification का दूसरा नाम होता है hormonal regulation. The second name provided to covalent modification is hormonal regulation. What are the two hormones that you need to know that plays a very key role in regulation, in regulatory pathways? Insulin and glucagon. अरे सोचो यार, you had food. Who comes into play? You are in fasting. Who comes into play? What is the role of glucagon? It activates an enzyme called as PKA. प्रोटीन काइनेज ए, पीकेए काइनेज है, देखो बेटा काइनेज है, क्या करेगा? फॉस्फेट ग्रुप ऐड करेगा, करेगा कि नहीं करेगा? Once the phosphate group is added, PDH becomes inactivated. Yes or no? You had certain thing, you had food. What came into play now? Which hormone? Insulin. Insulin is responsible for activation of an enzyme called as phosphatase. Phosphatase क्या करेगा? Phosphate group को बाहर निकालेगा. Removal of phosphate group in the form of inorganic phosphate. PDH becomes dephosphorylated. Covalently modified. PDH becomes active. अरे ये सुन लो, बराबर, ठीक है? कोवेलेंट मॉडिफिकेशन समझ में आया? ये इतना ही करना है, एक तरफ में हार्मोन ग्लूकागॉन रखो, एक तरफ में इंसुलिन रखो, यही करना है. सो वी कैन इन अ होल रेशियो कैन वी से दैट इन द प्रेजेंस ऑफ glucagon or when our cells are in fasting state, PDH complex gets inactivated. When we are in well-feeded state, खाना खाने के बाद PDH becomes activated. Yes or no? Am I clear? Now coming to allosteric regulation. Allosteric regulation समझने के लिए मैंने क्या बोला था? बुक नहीं पढ़ना है. You are not supposed to go through the book. You have to be smart enough. Smart enough in the sense, if this PDH complex is working, for what it is working? For what it is working? If PDH complex is working, for what it is working? What is the role? Production of acetyl-CoA and production of ATP. Huh? What is the role of acetyl-CoA? Either it can go to TCA cycle for again production of energy, or the acetyl-CoA can go for fatty acid synthesis. Yes or no? If your cell is having lot of energy, खाना खा लिए हो और सूत गए हो, energy requirement कम है ना? In that scenario, what do you think? The PDH complex should work or not? In that scenario, what do you think? Your PDH complex should work or not? You have high energy. That means what is the ratio? ATP to ADP ratio is high. When your cell is having low energy, the ATP to ADP ratio is low. Last time बताया था मैंने. हाँ, तो your allosteric effector should be high energy. When you are having high energy, what do you expect the PDH complex to be? Activated or inactivated? Jaldi bolo, क्या? Inactivated. What do you think if your cell is having lot of, cell is having less amount of ATP? Less ATP. Your cell is required of ATP. So PDH complex must be simple, yeah. Simple. Point number 2, the cell is having high concentration of reducing equivalents like NADH. NADH reduced equivalent है, NAD plus oxidized equivalent है. Okay, am I clear? So if the cell is having high concentration of NADH already, it will activate or inactivate this? जोर से बोलो. All of you stands for inactivation. Got the concept? So you have to look for the need of this reaction. Any reaction, you go to any reaction, you should look for the need. If the need of this pathway is responsible for production of energy, then if the concentration of energy in the cell is high, it is going to allosterically inhibit. If the need of the cycle or the pathway is for production of energy, again, but the concentration of energy is less in the cell, then the less amount of energy or less concentration of reducing equivalents or less concentration of ATP is responsible for activating this allosterically. Yes or no? बहुत simple है concept, okay? Apart from that, there are certain other components like calcium, magnesium. Calcium activates PDH complex allosterically because calcium is released from sarcoplasmic reticulum during excessive muscle contraction. In that point of time, your muscles requires a lot of ATP. So calcium allosterically binds to PDH complex and activates it, making the easy availability of ATP provided by acetyl-CoA, which goes to TCA cycle and gives your muscles energy or ATP. Okay. Importantly, if we talk about the deficiency syndrome of PDH complex, the major deficiency that causes the improper work, or you can say deficiency of PDH complex, is due to the deficiency of thiamine. Why? Because thiamine is an important coenzyme provided in this reaction. Okay, am I clear? Thiamine. Now, what can cause deficiency of thiamine? Berry, dry berry, wet berry, ठीक है? These are the conditions. We will discuss these things in detail. I'm not going to dig in that much. Okay. Chronic alcoholism causes the malabsorption of thiamine. Fine. So if there is a deficiency of thiamine, PDH complex will stop working, resulting in lesser formation of ATP. The cell will die soon. Okay. Fine. So the most commonest complication for deficiency of PDH complex is thiamine deficiency. Any cause resulting in deficiency of thiamine in your cell, in your body, will lead to improper functionality of PDH complex. Am I clear to you all? The last thing, I am not going to draw. We will just discuss with you guys. We are going to discuss because we are going to move now to TCA cycle. Okay, TCA cycle, is it new? Is that what you are coming in front of you like for the first time? Krebs cycle. Why it is called a cycle? Because it looks like a cycle ka chakka. Oxaloacetate. Yes or no? Oxaloacetate is how many carbon molecule? How many carbon molecule? 4. Very good. What we have inside the mitochondria? Matrix. Is a 2 carbon component. Fine. So what is the first reaction of TCA cycle? Oxaloacetate combines with acetyl-CoA, and forms a 6 carbon molecule that is called a citrate. Yes or no? Can you see there is something going to get joined? There is a joining. What do we need for joining? Energy. Okay. Energy. And the enzyme name is citrate synthase. Fine. Now you remember the enzyme classification that I have taught you? I have told you that ligases, whenever there is certain joining going on, joining bole to condensation reaction is going on, you specifically need what? Energy. Yes or no? So ligase is classified into 2 parts, synthetase and synthase. Yes or no? Synthetase, if there is a incorporation of ATP, the energy is taken away from by breakdown or catalysis of ATP. It is called as synthetase, right? And synthase, if ATP is not the energy donor. Yes or no? Yeah. In this reaction, where oxaloacetate combines with 2 carbon atoms of acetyl-CoA and converts into citrate, do you see any ATP involvement? Is there? No. Then where is the energy coming from? Because to join 2 things you need energy. Without energy you can't join anything. So where is the energy coming from? Anyone? Don't worry. Acetyl coenzyme. Okay. Partially she is correct. Where in acetyl coenzyme do we have enough energy almost equivalent to that of an ATP? Anyone? She's right. The energy is coming from acetyl-CoA. Where? The acetyl-CoA component looks like this. What is this bond called as? Thioester linkage that has got a -8 of negative delta G, free energy, -8 kilojoule, too much energy, and that is preserved in the form of thioester linkage between coenzyme A. इसीलिए wherever you see that a coenzyme A is getting added to any of the substrate, it requires energy. Whenever or wherever you see that a coenzyme from a substrate is getting removed out, the breakdown of the thioester linkage, you just have to think about that, okay, energy is released. Okay, it carries around -8 kilojoule of delta G, negative delta G. Lot of free energy. So that is the free energy that is required for the addition of 2 carbon molecules from the acetyl part of the acetyl-CoA to oxaloacetate forming citrate. Okay, the first reaction of TCA cycle is irreversible. That means if I am saying it is irreversible, what we need to say? It is going to be a key regulatory enzyme. Yes or no? It is going to be a key regulatory enzyme of the entire reaction. Yes or no? Fine. Chalo. Next reaction, isomerases. Fine, kind of isomerases, not isomerases, but citrate converts into, तुम लोग बोलो यार, aconitate, cis aconitate by an enzyme called as aconitase. What it does? It removes water molecule. First reaction. Okay, it removes water molecule, so the citrate converts into cis aconitate, and the enzyme name is aconitase. In the next reaction, immediately, it is a very unstable component, intermediate. It immediately, the same enzyme adds one more water molecule into it and converts into a component called as isocitrate. These are the three tricarboxylic molecules, and hence it is called as TCA, tricarboxylic acid cycle. So citrate, aconitate, isocitrate. These all are 6 carbon molecules with 3 carboxylic acids, or ending with the carboxylic acids. Am I clear? Next reaction, isocitrate is converted into a component called as alpha ketoglutarate. Yes or no? हाँ. This reaction takes place by, यहाँ पे ध्यान रखना, अब मैं एक एक पॉइंट बताऊंगा, ठीक है? Isocitrate is a 6 carbon component, converts into alpha ketoglutarate, which is a 4 carbon component. क्या हुआ? One carbon is lost. One carbon is lost in the form of carbon dioxide, CO2. Yes or no? Fine. So can we call this reaction as a decarboxylation reaction? Yes or no? Fine. Now, isocitrate, before converting into alpha ketoglutarate, converts into an intermediate. That intermediate is also very unstable. That is called as oxalosuccinate. Okay, so the first conversion of isocitrate to oxalosuccinate is provided by an enzyme called as isocitrate dehydrogenase. अब बेटा dehydrogenase है, तो what is going to happen? Dehydrogenation, that means H plus is going to get removed. Who should be the carrier? There should be someone. NAD plus will accept the H plus and will convert into NADH plus H plus. Yes or no? In the next reaction, as I told you, oxalosuccinate is not the original product, but it is an unstable intermediate. Okay, it will immediately convert into alpha ketoglutarate. So what is the difference between isocitrate, oxalosuccinate and alpha ketoglutarate? The number of carbon atom. Alpha ketoglutarate is 5 carbon, isocitrate was 6 carbon. So what you are going to do? A decarboxylation. There is no other enzyme. It is the same enzyme that is called as isocitrate dehydrogenase that removes the CO2. So this enzyme isocitrate dehydrogenase is performing a dual role. It is also responsible for the dehydrogenation. It is also responsible for the decarboxylation. That's why in any sort of reaction where you see the involvement of dehydrogenation with decarboxylation, we call those process as oxidative decarboxylation reaction. Am I clear to you? We call that reactions as oxidative decarboxylation reaction. Is that clear? Fine. So alpha ketoglutarate is what? A 5 carbon component. Next step converts into succinyl CoA. Succinyl CoA. See, one more coenzyme is going to get added. Okay. Alpha ketoglutarate is a 5 carbon component. Succinyl CoA is a 4 carbon component. What is going to happen? Again, one carbon is lost in the form of CO2. What the enzyme stoichiometry should be like? What we can call it as? Oxidative decarboxylation? Yes or no? And the enzyme name is called as alpha ketoglutarate. Fine. मजे की बात देखो. Alpha ketoglutarate is a multi-enzyme complex. ध्यान रखिएगा, 2 मिल गया आपको. You got 2 multi-enzyme complex. They generally ask you a short note on multi-enzyme complex. You have got 2. There will be one more coming. Fatty acid synthase. ठीक है? PDH complex and alpha ketoglutarate dehydrogenase complex is a multi-enzyme complex. Similarity या फिर इसको याद करने का तरीका पता है क्या है? ये जो apoenzymes और coenzymes दिख रहे हैं ना, अगर तुमने किसी एक के लिए याद कर लिया तो दूसरे के लिए you are comfortable with that. See how? I just need to change the name of pyruvate dehydrogenase and write it as alpha ketoglutarate dehydrogenase. Remaining all other things are same. Remaining all other things for alpha ketoglutarate dehydrogenase complex are going to be same as that of PDH complex. इजी है याद रखना, इजी है ना? फाइन, इज दैट क्लियर? We have also called PDH complex reaction provided by PDH pyruvate dehydrogenase multi-enzyme complex as oxidative decarboxylation. Same like that, alpha ketoglutarate dehydrogenase also stands for oxidative decarboxylation. Okay, next, succinyl CoA converts into succinate. Very good. How many carbon atom? 4 carbon atom. 4 carbon atom. Fine. Another point. Same like that of PDH complex, alpha ketoglutarate is also an irreversible reaction. Okay, so how many irreversible reaction have you seen till here? 2. Fine. Okay. Next, moving to succinyl CoA is converted into succinate, where the enzyme name is called as succinate thiokinase. इस point को समझिए, इस enzyme का नाम है succinate thiokinase. See, very interesting. Succinyl CoA converts into succinate. Where is coenzyme? It got removed. It got removed. So when succinate was bounded with coenzyme A, what was the bond? अब भी लिखा है thioester bond. It is rich in energy. Yes or no? Yes or no? So when succinate was there with coenzyme A, it was having a bond that was thioester linkage. So when you break that bond, coenzyme goes out. What you got? Succinate. But when you break that bond, lot of free energy is released. That much free energy the cell cannot allow it to go out or pass out. Am I clear? So it has to conserve it. It has to hold a part of it and conserve the energy. Free energy ऐसे waste नहीं कर सकते the cell. So you have to hold it. The cell wants to hold it. So for holding it, what the cell does, by utilizing the energy of thiolysis, breakdown of thioester bond, ठीक है, it adds a phosphate molecule in GDP to convert into GTP. We generally say what? That the terminal phosphate group attached to guanine triphosphate, guanine diphosphate, or adenosine diphosphate, the terminal phosphate group is rich in energy. You require a lot of free energy to make it, as well as when you break it down, lot of free energy is released out. We say that. Fine. So here the enzyme name says that succinate thio. Thio stands for thiolysis. आपको इस point से याद रहने वाला है. This is the point which will make you remember that okay, coenzyme A is going to get out of the reaction, and by using the thiolysis or the energy of the thioester bond, a molecule of GDP is attached with PI to form GTP. कोई मेरे से एक सवाल पूछना चाहे तो पूछ सकता है. अगर तुम्हारे दिमाग में ये सवाल आता है, if this question comes to your brain, why not ADP plus PI in this reaction? Why not ADP? Why it is GDP plus PI in this reaction? Because even though thioester bond produces enough free energy, but it is not enough to convert an ADP plus PI into ATP, because the terminal group of phosphate added to present in ATP has got more free energy. But for GDP, the ratio is less. The requirement of energy is less. As a result, this reaction cannot use ADP. But that's not a problem, because later on GTP itself converts into ATP. So ultimately you are getting an ATP. But for this reaction, directly you cannot incorporate phosphate into an ADP by using the energy provided by this thiolysis. Am I clear? Am I clear to all of you? Next reaction. Again, I'll just finish it up and then we'll go. Succinate converts into a component called as fumarate. What is that reaction? It's a reversible. All reactions are going to be reversible now. Succinate dehydrogenase. Can anyone say any exception for this reaction? Anyone say any exception about this reaction or this enzyme for TCA cycle? अरे तुम लोग पढ़े हो यार. You people have studied these things. Very good. Okay, that is one of the exception. This enzyme specifically needs FAD plus. It cannot depend on NAD plus. So that's why succinate dehydrogenase requires FAD plus and converts it into FADH. 2. Point number 1. Very good. Any other? Any other query or information about this enzyme comes as location of enzyme. What we say? That all the enzymes of TCA cycle are present in the mitochondria, the matrix of mitochondria. They are freely movable. They are mobile, right? They are present in matrix of the mitochondria. Bolte hai na? Arey hai ya na bolo. We say that with one exception. The one exception is succinate dehydrogenase. It is. I am not saying it is not present in mitochondria. Sorry, in the matrix. It is present, but the location is like that. It is just like this fan. Let us imagine that this roof is the inner membrane of mitochondria, and this is what the matrix is all about. You people are all other enzymes. This is succinate dehydrogenase hanging just like the fan. The active part of the enzyme is hanging, facing towards the matrix. Am I clear? Okay. Point number 3. Succinate dehydrogenase enzyme is responsible that participates in complex 2 of ETC that donates FADH2. Yaad aaya? Fine. Now, again same question. This reaction is common. What you might not know is important for us. Why this reaction needs FADH2, FAD plus? Why it cannot depend on NAD plus? Because the release of energy, it is all energetics, it is all about thermodynamics, okay? The release of energy, the release of heat in energy, whatever, is not enough provided by this reaction of succinate dehydrogenase to reduce a NAD plus. Because NAD plus is a higher reducing equivalent that requires higher energy state. So the energy released, the free energy released in this reaction is at lower energy state, and in presence in lower energy state, FAD plus can easily convert into FADH2. So that's why this reaction requires FAD plus to convert into FADH2. Okay. Next reaction, fumarate converts into malate. Malate by the enzyme called as fumarase. What is fumarase? Comes under the class of hydrolases. What hydrolases does? What hydrolases does? It incorporates water. Okay? Fine, it converts. So finally, fumarate converts into malate. The last reaction, malate converts into oxaloacetate, the 4-carbon component provided by a बहुत famous enzyme name. I call it as MDH. Malate dehydrogenase. Malate dehydrogenase has got lot of isoenzymes provided in isoforms that may be present in matrix, that may be present in cytoplasm. Okay, I am ending this class over here. But what I want just to say that for you guys, what questions you can expect from TCA cycle is what is anaplerotic reactions, what are amphibolic reactions. What is it? What is anaplerotic reaction? What is amphibolic nature of the reaction? Why do we call it as there are certain significances of TCA cycle. You just go through that once. If if you find any doubt, please approach me wherever you see me in the campus. In Vasudevan textbook, they have given significances of TCA cycle in a green box. Okay, you just go through those points. If anywhere you find difficulty, you can approach me directly anywhere. Okay. Next point, regulation of TCA is important. मैंने already आपको बोल दिया है. It is always dependent on the production of energy. See, one more thing. TCA cycle is not regulated by hormonally. Remember this point. TCA cycle is not regulated hormonally. Yes or no? No insulin, no glucagon. So TCA cycle will be only regulated by the energy level provided in the cell. If energy status is high, TCA cycle block. If energy status is low, TCA cycle goes on. Yes or no? But no insulin, glucagon. No addition of phosphate group, no removal of phosphate group for reactions, irreversible reactions of TCA cycle. Am I clear to you all? Am I clear? Thank you.